Hi guys, here's our fourth lesson on transformations. We're going to talk about dilations today. A dilation is a transformation that produces an image that is the same shape as the original but different sizes. Okay, so think about when you resize something on the computer, like a picture you've clipped in and you just drag the corner. It's the same shape, it's just a different size. So that's kind of what we're talking about. We're resizing something. So a dilation is similar to the original figure. Dilations are centered around the origin unless otherwise, so it's centered around the origin 0, 0, unless otherwise stated. Okay, so here we go. We're going to talk about scale factor now. Scale factor is the image length over the pre-image length, which is a ratio. Okay, if the scale factor is greater than 1, the figure becomes larger. And if the scale factor is between 0 and 1, the figure becomes smaller. So I want to talk about between 0 and 1. So that can be a decimal, right? Or a fraction, but not all fractions are between 0 and 1. So the only fractions that are between 0 and 1 is where the top is smaller than the bottom. But if the top is bigger than the bottom, then that's greater than 1. So I just want to make sure that that is kind of understood. Okay, so we're going to go ahead and go on to the next little page here. Okay. Okay, so it says the rule. So this is how we write the rules for dilations. XY goes to FX FY, where F is my scale factor. So if I have a number and two letters right next to each other, mathematically, what do I do to them? Well, I multiply them. So basically it says XY goes to F times X, F times Y. So if the scale factor is 3, how would I write the rule? Well, the rule would be XY goes to, remember I always have to have that part, XY goes to 3X, 3Y. So I take X and I multiply by 3, and I take Y and I multiply by 3. Not too bad, right? Okay, so the next little spot says, or problem, says what triangle ABC has vertices A, 0, 2, B, 4, 4, and C, negative 1, 4? What are the vertices of the image with a scale factor of 4? So I'm going to write out my rule here. So I've got XY, and it goes to 4X and 4Y, right? So that's what I want to do to it, do to each of my points. So A is 0, 2, and it would become A prime. And now I'm going to multiply by each of those points, my X by 4 and my Y by 4. So 4 times 0 is 0, great. And 4 times 2 is 8. And there's my new point. And then B is at the location 4, 4. And we're going to go to B prime. And 4 times 4 is 16, yeah. And 4 times 4 is 16, beautiful. And C is at negative 1, 4. And again, I'm just going to multiply each point by C. So 4 times, I'm sorry, by C, by 4. So 4 times negative 1 is negative 4. And 4 times 4 is 16. And there's my new points. So is that going to be bigger or smaller than the original image? Yeah, bigger, good. Okay. So here we're going to do some on a graph. Okay, so quadrilateral PQRS has vertices P, negative 2, 4, Q, 4, 4, R, 4, negative 2, and S, negative 4, negative 4. It is dilated by a scale factor of 1/2. What are the coordinates of the image? Graph them. So I'm going to, oops, let me erase that. Let me move this over a little bit so I have some space to write. Okay, so we're going to graph the points first. So P is -2, 4. So I've got P. And Q is 4, 4. So that's Q. And R is 4, -2. And S is 4, -4. So this is S. So I guess it looks like a little kite here. Beautiful. Okay, so now it wants me to find the coordinates of the image and then graph them. Okay, so P, we know P is at -2, 4. And that goes to P prime. So what is my rule? I'm going to write out my rule here. So X, Y goes to negative 1/2 X, 1/2 Y. So I'm multiplying by a half, or I'm taking half of each of them. So half of -2 would be -1, and half of 4 would be 2. So P prime is -1, 2. So here's P prime. And Q is at 4, 4. And it would become Q prime, which would be 2, 2. Q prime. And R is at 4, -2, which is going to become R prime, which is going to be 2, -1. So 2, -1, R prime. Great, I guess I can draw those in already. Okay, and then S is at -4, -4, and it's going to become S prime, which is -2, -2. So S prime. So there's my figure. Okay, so, oops, part B says, demonstrate that these quadrilaterals are similar by comparing the ratios of their length. Okay, so we're going to talk about the lengths, and we're going to talk about the lengths we know. So I know that PQ is, how long is PQ? 1, 2, it's 6. And I know that P prime, Q prime is 3. So that simplifies, so that would be a ratio of 2 over 1, yeah? And then we're going to do QR, because I can't read my own writing. QR is also 6, and Q prime, R prime is 3, which simplifies to 2 over 1. So they are similar because similar means that the sides are equal. Like, I can't even talk. The sides are proportionally equal. There we go. So 6 over 3 is the same as 6 over 3. Woo! Okay. If I simplify it down, I get the same number. And then, oh, can I fit it on here? Yeah, I can. Okay, good. Then the last thing is, what do I notice about the angle measurements of the two figures? So the nice thing, if I could take this, my image, so the P prime, Q prime, R prime, S prime, and move it and slide it down so that S prime is on top of S, you would see that it was exact same angles. And R prime is on top of R. You could see that it was the exact same angles. But unfortunately, this program doesn't allow me to do that part. What do we know? The angles, they are equal. Or, if we want to use our right word, congruent. They're congruent. Equal in size, similar in shape. Okay? So, if it's a dilation, the angles are equal and the sides are proportionally equal. Okay? So, we need to use that word, proportionally equal. Okay. So, one more page, a few more examples, and we're going to have you do some dilation homework. Or problems, sorry. So it says, if the scale factor is 5/2, how would I write a general rule? And is it an enlargement or a reduction? So I'm going to write the rule, and the rule always starts out with xy goes to what? Well, 5/2 x, and yes, 5/2 y. Good. Good job. So is it getting bigger or is it getting smaller? Well, remember we're talking about the fraction between, is the top number bigger than the bottom, or is it smaller than the bottom? Well, in this case, it's bigger than the bottom, so that means it is an enlargement. If it was like 1/2, then it would be a reduction. Okay, so it has to be, in order for it to be a reduction, the top has to be smaller than the bottom. If for an enlargement, the top would be bigger than the denominator. So the numerator would be bigger than the denominator. Okay. So quadrilateral A prime, B prime, C prime, D prime is a dilation of quadrilateral A, B, C, D. Find the scale factor and classify the dilation as an enlargement or a reduction. So how you do this is you find 2 points. You either find the A prime, you use the A and the A prime, the B and the B prime, the C and the C prime, the D and the D prime. I try and find an easy one. In this particular case, they're all fairly easy. So I'm going to choose A and A prime. Okay? So I know that A is at, where's A at? A is at 6, 0, which goes to A prime, which is at 2, 0. Okay? Right? And so how do I do my rule? Remember my rule says xy goes to, fx, fy. So what I'm trying to find here is this f. I want to know what I'm multiplying by to get 2. So what am I multiplying x by to get 2? So what I'm saying is, what do I multiply this by to get this, right? Is basically what I'm saying. So what do I multiply 6 by to get an answer of 2? And that's what this says. F of x needs to be my y term. So what do I multiply 6 by to get 2? Well, now it's just an equation you know how to solve. So now I'm going to divide by 6, and f is going to equal 2 6, which is 1/3. So my dilation is 1/3. My scale factor is 1/3. So now is that an enlargement or a reduction? It's a fraction, right? So is my numerator smaller than my denominator, or is it bigger than my denominator? Well, 1 is smaller than 3, so that means this is a reduction. Okay? Nice job. Okay, and then the last one says, triangle XYZ is graphed below. Draw and label triangle X prime, Y prime, Z prime after a dilation using a scale factor of 2. Okay, so my rule is going to be XY goes to 2X, 2Y. So I'm going to multiply it by 2. Okay, so that means X is -1, -1, which goes to X prime, which is -2, -2. I'm just going to go ahead and write all these out, and then we'll graph them. So Y is -1, 2, which is going to go to Y prime, which is -2, 4. And Z is 1, 1. And it's going to go to Z prime, which is 2, 2. Okay, so here we go. So -2, -2, -2, -2 is X prime. -2, -4 is Y prime. And 2, 2 is Z prime. So here is my new figure. Great. Okay, so then it says, what will the coordinates of point of y double prime, what will be the coordinates of point y double prime after a reflection of polygon x prime, y prime, z prime over the x-axis. So now I just want to reflect it over the x-axis, and I'm only reflecting, they only want to know about y, so I'm just going to reflect that one. So it's 4 up, so it'd be 1, 2, 3, 1, 2, 3, 4 down. So this would be y double prime. Well, what's the location of that point? So, well, y double prime would be -2, -4. And that's it, done. And that finishes our 4th lesson on dilations for our transformation unit. We will see you next time. Have a great day. Thanks. Bye.